what we're going to do is standardize it. Lovely. Mu and mu plus a standard deviation, or mu minus a standard deviation, and we found an x value. Now we're going to think of it a little differently. Dun, dun, dun. We are now going to look at these in terms of 0 being the mean, and instead of plus 1 and minus 1, we're just going to call them 1 and negative 1, as in our sigma limits. So what is this called? The standard normal curve. How do you get from one to the other? Look down, my friends. There it is. It's called a z-score. A z-score is found by taking your x value, subtracting the mean, and dividing by the standard deviation. Don't you just want to go color Easter eggs? The trick to these is make sure when you do them, you're rounding your places to 2 decimal places. Notice the position of the arrows. This first arrow is in relatively the same position as the second arrow. That'll be important when we go to do these on our own, like now. Given that mu is 40 and the standard deviation is 5, calculate the standard score. Remember the concept of standard normal curve? Hence we have the standard score. Very creative. And we're going to indicate where this would show up on our normal bell curve. Well, let's move this out of the way and give me some room to work. The formula was z equals x minus mu divided by the standard deviation. Well, they're telling us that x is 33. So I'm going to put 33 in the x spot. And they're also telling me that mu is 40. So I'm going to put 40 in the mu spot. And finally, standard deviation is 5, so I will put 5 in the standard deviation spot. Call up my rusty trusty calculator, and I will say 33 minus 40 divided by 5. Oh no, it's a decimal! Don't panic. Negative 1.4, which means that my z-score equals negative 1.4. What is a z-score? Well, yeah, it's a calculation and it puts it on a normal curve, but what is it? I like to think of it as a non-nice number of standard deviations. Think miles. You could drive 1 mile or 2 miles or 1.2 or 1.4. It has the decimal value in it. The negative that you see in our particular problem refers to the direction. It is below the mean. So when I go to draw this, there is the mean. Here would be 1 sigma limit, 2 sigma limit, 3 sigma limit. Yes, I know, I'm going the wrong direction. Negative 1 sigma limit, negative 2 sigma limits, negative 3 sigma limits. But where does this one go? Here's 1. Here's 2. It's in between them. So we would say that this z-score falls right about here. That's where we find z equals negative 1.4. Negative 1.4 standard deviations below the mean. Let's try almost the same problem, but in this case, x is going to be not 33, but 51. And let's see what happens. We're still working with a z-score, so we're still using the same formula, x minus mu divided by the standard deviation. Substituting our values, x is 51. Mu, from up in the problem, was 40, standard deviation of 5. 51 minus 40 divided by 5. I'm pretty sure that 51 minus 40 is not 9. How about 11 divided by 5? After that, I think I'm going to get my rusty trusty calculator back into this. 11 divided by 5 equals 2.2. It's a positive number, so this z-score of 2.2 is going to be above the mean. So when we go to draw this in, here's my mean. 1 standard deviation, 2 standard deviations, 3 standard deviations. 2.2 is not 1, it's not 2, it's a little more than that. It would be about here. The z-score, x minus mu divided by standard deviation. In this scenario, x is 45, mu is 48, standard deviation is 5. I'm going to have negative 3 divided by 5, which is negative 0.60. It's negative, so this will be below the mean. When I go to draw this in, here is my mean, here is 1 standard deviation below, so this particular z-score falls just beyond the halfway mark, right here. This pretty chart right here is called a standard normal distribution table. What it gives us is a z-score, and the inside is a probability. Key notion here. The probability given in a z-chart is the same as the percent of the curve is this not to calculate a z-score nor to draw it, but to find it on the chart. If the z equals 0.71, meaning 0.71 standard deviations above the mean, what is the probability? So you go to the chart and you follow along the 0.7 line. And then the second decimal value of 1, follow along that line. And you find the value right at the intersection, right here. You would say that the probability of finding a z-score would be 0.7611. That would also mean that 76% of the curve, that if I were to draw this particular curve, watch out, I'm a trained professional. In my standard normal curve, if this is the mean, here's 1 standard deviation, 0.71 for a z-score would be here. But now what I know is that 76% of the curve is shaded behind it to its left. Shadings are always given to the left. To the left, to the left. Let's try another. Now let's find the probability of getting a z-score of 0.14. You're finding the probability. 0.1 traced with 0.04, which becomes 0.14 when put together. Oh, I love this part. Hello! The probability is 0.5557. A pictorial version of this. Why? Because I can. Would look something like this. There's the mean. There's one standard deviation, but this is pretty close to the mean. It's only 0.14 standard deviations. Somewhere around here. Everything shaded behind it is its probability. If I ask you for a z-score of 0.03, if I asked you what percent of the curve is to the left of 0.50, the percent to the left would be the same as the probability. And you would tell me 0.50 gives a probability or a percentile or a probability to the left, area to the left. Those all mean the same thing, of 6915. This is the z-table that I prefer to use because this one actually gives you positives and negatives. And if I can truly highlight for you the bell curve here at the top, the area that they're referring to is what I said. It is, in fact, to the left. So what if I give you a negative z-score and I ask you to find for me the percentile or probability or area to the left when the z-score is negative 3.16. The process is the same. You just have to be extremely careful about these negative signs. 3.16 would take us negative 3.16. A little bit difficult to read, but you could safely say that the probability, or what percentile is that? That would be 0.0008. You're not even in the first percentile. Distribution table that I prefer to use because it gives us negative values. So if I ask you what is the probability or percentile or area to the left of a z-score that is negative 2.57. Remember what this means. 2.5 standard deviations below the mean. We're talking about something very, very small over here that would be shaded. What is it? Following the negative 2.5 line, and this chart is also a little bit bigger, so it goes further than just the 0.06. Tracing that down with 0.07, you can see it highlighted in the pretty periwinkle. The probability would be 0.00051. 1. Again, everything we've talked about has been to the left. Percent of the curve and percentile to the left. Positive and negative that have been provided to you to see if you can read these. And then check your answers. Negative 1.84, the area to the left of that. P equals 0.0329. Reading the positive z chart, because we have a positive number here, the percent of the curve to the left, 0.9788. And finally, if you have a z of 0, you're on the mean. It has been cut in half. Half of the curve is to the left. Half of the curve is shaded. You are in the 50th percentile. One more time. Probability is the same as the percent of the curve is the same as the percentile. Same answer to different questions. Now let's consider something a little different. In all of our previous examples, we've had left. Now we're going to look at the right-hand side of our graph. In order to do this, we need to recall that probabilities, whether you're flipping coin or you are rolling a die, probabilities always add up to 1. Half plus half equals 1. All these probabilities on the inside equal 1 also. So if I'm given, for instance, a z-score that produces a probability of 0.70, what would be left to be shaded in here? Well, you would take 1 and subtract that 0.70, meaning that to the right of the z-score, 30% is now shaded. Likewise, if I told you that 80% of the curve was to the left of the z-score, what percent then would be to the right? Using the notion of probabilities add up to 1, you would simply subtract 80% from 1 and find that that might be 20%. Picture not drawn to scale. So let's consider some more examples. If the z-score is 0.02, you would find the probability at 0.02, 0.5080. But we're looking at areas to the right, so we'll have to subtract 1 minus 0.5080 to get our correct probability. And we'll find that the probability is truly 0.492. I caution you once again to think about what that looks like. A z-score of 0.02 would be very close to the mean. Just a little over half would be to the left, which means just a little under half, 0.492, 49%, would be to the right. In our second example, we need to switch charts and work with a negative chart. Everybody read that one just fine? I'm old. Let's make it big. Negative 1.93. Negative 1.93. I had to switch charts to grab the negative, but I'm still looking at areas to the right. So the probability that I'm going to look for will actually be 1 minus what I have circled, 0.0268. The probability of getting a z-score of negative 1.93 or less, or I could ask, what is the probability of getting a z-score that is larger, since we're talking about to the right, negative 1.93? Probability is pretty high, 97%, because we're looking at negative 1.93 being down here, but we're talking about not the left, but to the right, most of the curve. So it should make